All right, we're done with Tableau, and today we're going to start what will continue for the next 10 weeks, and that would be learning data analytics, or machine learning, or data mining, however you want to call it, and we're going to use a certain tool which is called R. Okay, so let's discuss what R is, and I'm going to show you today. I don't have a big plan, quite honestly, for today, but I'm going to show you a few kind of introductory things and ideas about programming. Okay, so I'm going to make full screen, just like that. Introduction to R. Well, first of all, let's talk about what is R. Okay. R is a statistical package and a programming language for that statistical package. Okay, you can think of R as one of the programs that's used for data analysis, but it's not the only one. Okay, so a few years, well, 2 years ago, in this course, we used something that's called JMP, J-M-P. Okay, it's very straightforward, well, fairly straightforward to use tool, but it's not very popular. Okay, that primarily was the reason why last year I decided to not use not use JMP in this class and switch to R primarily. Currently, at the moment, R is one of the two top tools to do the data analysis in the companies. Okay, the other very popular, hugely popular tool right now is a programming language called Python. How many of you heard about Python before? Yeah, Python apparently is becoming so popular right now that it is the programming language #1 in the world, and it took the first place from another programming language called JavaScript. JavaScript is hugely powerful language for the web programming. So, you know, program behind the web pages. Okay, a lot of people know JavaScript as the language, the programming language that enables dynamic and very interactive web pages. For example, you point on something on the web page, then it expands, and as you scroll the mouse, you know, different parts are getting selected. So very dynamic, hugely interactive web pages. But it's also it enables to write programs behind the web pages that are executed when you interact with the web page. So it's hugely powerful, and up until recently it was #1 language in the world. Okay, Python took the first place. I believe it happened in this year, 2019. Okay, so R and Python are both very popular, and I had to make a choice essentially which one to use. Okay, in this course, Python or R, and I picked R. Maybe in the future we'll change it. I don't know. Right, but R is one of the top ones. Okay. Another popular tool to do data analytics these days is something that's called SAS. SAS is a company, actually. It's North Carolina-based company, and they own JMP as well, the tool that we used up until recently in this course. Now, the difference primarily between Python, R, and SAS is that Python and R require you to write programs. Okay, so they require you to do the coding by hand, essentially. And SAS is very much a drag and drop environment. So it's like JMP in a sense. Okay, you don't have to even see the data. You can do, you know, the entire data analysis by dragging different elements by mouse onto the canvas, connecting them. So it's a very visual environment, but it's not free. That's the downside. Okay. So I guess the reason why R and Python are so popular, that they share #1 and #2 places in the world of data analytics, is a large reason is because they're free, both of them. Okay, Python and R are free. So R as a package was started back in 1993. Okay, and originally it was purely statistical package. The material that you guys learned in VOSN 231, Introduction to Business Statistics, right? Remember, you did hypothesis testing, right? You calculated the p-values, you calculated the confidence intervals, right? You did the histograms, means, standard deviations, all these things that traditional statistics does, right? And that was R back in 1990s, okay? But recently it became very popular, and you will, and I'll tell you the reason why it became very popular. Why all of a sudden this tool took like number 1/number 2 in the charts, okay? First of all, let me show you how to get R. Okay, so you need to download R and install it on your machine, no matter what you use. Okay, it can be either. All right, it can be either. Let's do this. Mac or what's it called? PC. All right. So go to Google and type R. Just one letter, R. And do the search, and the very first thing that will come up is going to be the link to rproject.org. Okay, so click on that link. It will take you to the R web page, and it's all in my slide, right? So download. Click on this link, and it will take you to the list of servers where you can get the download. You can download it from any one of these servers. It's the same thing, really, okay? So, for example, if you scroll to the list of the USA locations, right? I don't know, Indiana University. I'm going to click on this one. It takes you to the Indiana University, and you can see how many of you have Linux right now? Nobody, yeah. Okay, so you have either Mac OS, if you have unfortunate user of Macintosh, right? Or Windows if you have a PC, right? So either one of them. So you have to download and install this one, okay? All right. So that's going to be your homework. Download and install R on your machine, okay? All right. Okay. So, like I told you minutes ago, unlike other popular tools such as SAS or JUMP, R is not user-friendly. By far not that user-friendly as JUMP. In JUMP, you just click on things that you want, right? There are menus, right? And you have to pick the right option on the menu, and the window shows up. You drag the variables, right? You set up different things that you want to do. Then you click OK, bam, and there is output for you, okay? R is not, and Python, same thing really, okay? Is not like that, okay? In order to run R or Python, you essentially need to write programs. We're going to call them scripts, okay? It's just a bunch of lines of code. So what's a program? Program is just a bunch of commands, right? Each line represents one separate command. So you write programs line by line, your code line by line, and after that you execute the entire script, and the software shows you the output, and our job essentially is going to be to interpret the output that the program is giving to us. Okay, that's essentially it. All right. So why R is so popular? Well, like I said, R is free. Okay, so companies essentially have to make a choice. Okay, let's say company XYZ wants to do some analysis, okay, of data, statistical analysis. They have few options. Option number one is to buy really easy to use tools such as JUMP or SAS. Okay, for these tools you practically don't need to know programming, which by the way is not entirely true. You still have to know the programming behind the scenes. But most of the things that you do in SAS, you can do it by just dragging and dropping things, okay? The downside, so upside is that it's easy to use, right? Point and click, that's what it is. Downside is that this is expensive, okay? These are commercial products, and SAS is especially expensive. If you want to use R or Python, tools are free, okay? But guess what? In order to do the analysis, you have to hire people who know how to do statistical analysis by writing programs, right? By writing scripts, the code. And that is going to be your expense essentially. So the tool is free, but working in this tool is not free. You're going to need to hire people who are professional, proficient with writing code in R or Python, whichever one you want to use, okay? So free is one thing. about R, why is it so popular. But that's not the only thing, okay? What makes R truly powerful is the fact that it has a lot, and by a lot I mean, as of right now, I think nobody really knows how many libraries it has, okay? Last year, it was somewhere in the neighborhood of 7,000, I believe. And the list is always growing. See, R, by itself, native R, like naked R that you download and install, cannot do a lot of things. For example, it can do the regression, simple regression, but it cannot do the classification tree, okay? So how do we create classification trees using R? Very simple. We download library literally from the internet. And I will show you when we start doing the classification trees, what does that mean to download the library. Okay, it's very simple. It's done literally in one line of code. Library goes to your computer, you install it, and now you can create classification tree using R. The thing that R could not do to begin with, but now it can because we downloaded the package that expands our functionality and allows it to do things that are not natively built into it. Okay? So there are packages available for R that can do all kinds of stuff. You can do highly sophisticated interactive graphs. Okay? Something that R cannot do by itself, but there are packages that allow you to do that. Okay? That's called R Shiny, for example. Okay? You can do classification trees, you can do neural networks, you can do support vector machines that we're not going to discuss in this class. So a lot of things that data scientists came up with are implemented as libraries. And these libraries are freely downloadable from the internet. Okay? And there are literally thousands of them. That's why R, second reason why R is so powerful. Okay? If somebody wrote a package, a piece of code, a library, and made it available to the public, most of these libraries are available to the public for free, then you can pretty much do any type of analysis with your R. You just need to download the right package and start using it, okay? That's the second reason why R is so powerful, okay? The functionality is huge due to the fact that there is a community who built these libraries. People, researchers, okay? Whoever has an interest in that, and they typically do it for free, and they make the code available to the world, okay? So there are thousands and thousands of libraries that can do all kinds of computations, build all kinds of models, and that's, like I said, the second reason why R is so popular, okay? Now, let's discuss difference between interpreted. How many of you had programming language experience before? Any kind of programming language? Okay, John? What was that? Java? Okay, good. Anybody else? All right. That's normal. Okay. Most people probably, at least taking this class, never had a programming language before, never used it. Okay. There are two types of programming language. Okay, interpretable and compiled. What's the difference? Compiled, C++ is a good example. Okay. If you write a program in C++, a bunch of lines of code, okay, you cannot just punch the run button and the program will start running. First, you have to run the program through another program which is called compiler. What compiler does basically is it starts looking at the code line by line and makes sure that your code looks right. It doesn't know what the code is doing, quite honestly, and there is no way to know, right? But it's looking at your, well, called syntax, okay? Did you write the commands correctly? Did you forget any kinds of like commas, okay? Or if certain function requires two parameters and you're sending only one, it's going to spit out the error, okay? So it checks if you correctly wrote the code from the syntax standpoint, okay? It's pretty much like writing a paper, right? On your report. Okay, there is certain order of words in the sentence, right? There are rules where you should place commas, right? There should be a dot at the end of every sentence. The first letter of the first word of the sentence should be capital. So there are certain things that program can check, right? That's what compiler does essentially. It checks that program looks correct, okay? And then it converts the program into the special type of file which you can execute on the computer, executable file, okay? So first, if you wrote the code in C++, you have a bunch of lines of code, you run them through the compiler, it gives you the executable file, and then you can run the file, and the file does, whatever it's supposed to do, the code runs, okay? So that's compiled programming languages. R and Python, both of them are not like that. There is no compiler. There is something that's called interpreted programming language. What does that mean? That means that, for example, let's say I wrote a program with 20 lines of code, okay? And I made an error in line number 12. When I hit the run button, it will execute 11 lines just fine. It will show me the result if it's supposed to show anything. But on line number 12, it will say, uh-oh, there is a boo-boo somewhere right there, okay? So I'm quitting. You go ahead and fix it, and you can rerun this thing again, and you're done. So it executes things line by line until it finds the error. It doesn't look at the correctness of the code to begin with. Pretty much line by line execution. So R is like that, okay? You can have, like I said, 20 lines of code and error in the middle. It will start running. But the moment when it cannot execute the next line, it will quit, and it will throw you a red message that says, ooh, error, okay? Cannot go any further. Okay. So RStudio, what's RStudio? Well, first of all, you know what? Let's go ahead and take a look at R, okay? Let me go ahead and exit out of this thing. You have R actually installed on this machine, or at least you should have it. So, here's what I'm going to do. Look at your desktop. Do you see a funky looking symbol that looks like a gigantic letter R with like oval around that? Double click that. Yeah, double click one of them. Okay? I'm going to do the same thing. So I have R right here. That's what R should look like. Do you have the same? Okay? Everybody? Are we good? Okay. So this is R. Okay? Plain, simple R. Well, you can see that there is some information about R package, etc., etc. And then there is blinking vertical line called, what's it called? Blinking line that says, yep, I'm ready for the input. Cursor, right? Yeah, cursor. And so it expects an input from us, okay? So I can go ahead and say 2 plus 3. Okay, we're going to start slow, right? Elementary stuff. When I hit enter, it says 5. 10. Okay? I can go ahead and say 10 divided by 2. When I hit enter, we're going to say same thing, 5, right? Okay. Or I can say x equals to 4. And when I say that, that means that I just created a variable and I assigned the variable value of 4. Okay? And now this variable contains the value of 4. Now I can print it out. What's inside 4? I can go ahead and say x. And when I do that, it will say, yep, x has 4 inside. Okay? So you can see that I'm pretty much writing the line, hitting enter, and then it runs the line, right? Okay? Okay. So, well, ladies and gentlemen, this is the first and the last time when we're going to use R straight as it is. Okay? We will not use R directly through this interface. You can see that there is no point and click, right? It's very user unfriendly. You have to write commands line by line, right? This is something that's called command line driven environment. Okay? So you type the command line, hit enter, it executes. Okay? So this is what R looks like. There is another program which we're going to use, okay? Make sure that you use that program during the tests, exams, and group assignments, because a couple of semesters ago, halfway through the semester, I was usually surprised to see one of the students who sat right at the end, next to Tikalani, okay? Some of these places. Like everybody is using RStudio and he was still using R. I'm like, how did that happen? It was only 2 months since we stopped using R. Okay? And you're still doing that. I don't know how that happens. So we're going to use something that's called RStudio, okay? And that's another thing that you need to download and install on your machine, RStudio, okay? So how to find RStudio? It's very simple. Let me show you first, okay? So same thing, you go to Google and you type RStudio, and when you hit enter, the very first link that you will see is exactly that, okay? There you go. RStudio. Then you go to Products, RStudio, and there are two flavors of RStudio. Okay, there is a desktop and there is server. Is there a download? Do you see download? Not quite yet, right? We need a desktop. Okay, just like what we use Tableau desktop, right? Now you need to download and install RStudio desktop on your machine. So when you click on the desktop, there are two options. Okay, open source edition or commercial license. Commercial license, as you can see, is about $1,000 a year. Do not download this one. Okay, download open source edition, which, as you can see, is completely free. This is going to be our primary tool in this class, RStudio. Okay, we're going to run the program, and RStudio basically runs on the top of R. Okay, you don't see it, but what it does is in RStudio we're going to type the program line by line. We're going to create our script. When we hit the run button, RStudio will call R, which is installed on the same machine, right? R will run, spit out the result, pass it on to the RStudio, and RStudio will show it to us. So essentially we're going to be using R behind the scenes, but we will never see it. Kind of part of the RStudio. RStudio interacts with us, okay? Alright, so how to find RStudio? They're also installed on your machine, okay, RStudio. So let's go ahead and do that. I'm going to, so let's do this, okay? There is a way to find RStudio on your machine. So you just click the start button and start typing RStudio, and it will show up, right? As you start typing RStudio. Correct? It did show up. So let me show you what to do. So I'm going to do the same thing here, RStudio. So when you find RStudio, right click on RStudio, and one of the options should say pin to the taskbar, right? Okay, go ahead and say pin to taskbar. What it will do is the icon for the RStudio will show up at the bottom of your screen, right? Okay? Okay. I already did that, so RStudio is already here. So let's go ahead and launch RStudio. Just click on the icon in your taskbar, and it will launch like this. Right. So this is going to be our primary tool. We will do all of our analysis in the next 10 weeks, 9 weeks. Okay. Do you see the same thing with me? Or not quite? Alright, well, let me kind of walk you through, okay? If you see the same thing, 3 windows, right, as I do. I have 3 windows. Some of you, how many of you see 4 windows? Nobody? Okay. So, let's go ahead and add another window, actually. So, do you see the plus sign on the top, in the upper left corner? Go ahead and click the plus sign, and the first thing it will say is RScript, right? Okay, so go ahead and create, that basically means create a new RScript, start a new program. And then it will create 4 windows for you, right? Okay, good. So RStudio has 4 windows. Let's kind of briefly talk about that. This window is going to be our main window where we write, this is editor. This is where we write our program line by line, okay? Then when I hit the run button, which is right here on the top, alright, when I execute my code, then the result of the code execution, the output, will be shown right here at the bottom. Okay? So these are going to be my 2 primary main windows that I'm going to use. This window in the upper right corner, I find it the most useless, but that's just me personally. Okay? It shows you history, like which program, which lines you ran, It shows you variables. We're going to discuss variables in just 1 second. But I very rarely use that window, okay? So we're probably not going to be referencing that a lot. The last window on the bottom right is also fairly useful. You will see that over here, every time when I plot a chart using R, it's going to show up in this area. Okay? Bar charts, histograms, scatter plots, all these things. Also, sometimes I'm going to need to use help, and I will show you how to use help. So if you're looking for help with certain function, the help will show up in this window as well. So our main windows are going to be code editor and the what's called console. That's where the results of our program or of our script are going to be shown. And this one right here, help / show me the chart window. Okay. All right. Well, let me start by saying this. Since none of you, how many of you? I asked you this question. Right? Nobody had practice writing the code, right? So let's start with kind of getting into the mindset of programming. Oh, that's just my. This is old stuff. I didn't do anything. Yeah. So this is from my previous run. Okay. Should be clean actually. I don't know why it's showing here. Okay. First is generally speaking, it's a good programming practice to leave comments or notes. Okay? Why is that? Because sometimes when you write a program and then you open the program the next day or a week from now, you don't exactly remember what you did last time. So you wrote some lines, but you don't remember what each line does. So it's kind of a note for yourself or whoever else is going to read your code, like me, for example, right? When you submit your assignment, I get the code from you, and I want you to tell me what this line does, what this line does, okay? So that's what's called comment. In R, and in Python, by the way, same thing, okay? The comment looks like this. You have to start it with pound sign. So just type the pound sign. And after that, I can type whatever I want. For example, this is a comment line. Now, okay. You want me to make it bigger? Okay. Yeah. Magnifier. Hold on. How is that? Big enough? Or even bigger? Bigger. Okay. Let's do 200%. How is that? Good? Okay. This is a comment line. Now, the magical symbol here is the pound sign in the front. Alright? So each time when the R, I'm going to run it in R, in just 1 second, okay? Each time when R sees the pound sign, then it ignores the rest of it, okay? So you can type whatever you want. It's not going to be executed because it's not a command, right? It's just a mental note for myself. What's this thing that's going to be typed next line? So there are a couple of ways how you can execute a line of code in R. You can either click on the run button at the top, okay? Or you can go ahead and hold down Control and hit Enter. And then the blinking thing, which is called how? Cursor. You're going to jump to the next line, and nothing will happen, right? So there is no output. I didn't ask R to do anything, really. It's just a mental note for myself, okay? So this is a comment line. Well, I'm going to actually do something meaningful, okay? So instead of saying, this is a comment line, how about this? I'm going to say, this is variable X. This is a variable X. And I'm going to use lowercase x, okay? You will see in just 1 second why is that important. Now, what are the variables? Variables are chunks of memory. You know that computer holds everything inside the memory, right? At the beginning of class we discussed how to measure the memory, right? Remember our discussion about bytes, kilobytes, megabytes, gigabytes, etc., okay? So a variable is essentially a small chunk in the memory which holds some data. It can be numbers, or it can be string, characters, or it can be anything, okay? And I have a way to put information inside this memory or get it out, okay? For that, I need to have a name. for the variable. This is how I access the memory space, okay? If I call it x, so I'm going to type x, and then the next thing that I'm going to do is record number 5 inside the variable which I called x. In R, it's a little bit weird. In R, there are 2 ways how I can record information inside the variable. I can just say equals 5, and that will be just fine. That would be enough, okay? When I run the program, how do I run the program? I can either click on the run button right here, or I can hit what? Control, enter, right? So I'm going to go ahead and hit Control, enter. On the next line, right here, Control, enter, and it says x equals 5, right? So now I allocated inside the memory small chunk of space, okay? And I recorded number 5 inside this memory, simple as that, okay? So if I want to find out what's inside my memory, which I'm calling x, right, inside this chunk, I'm just going to go ahead and say, print x for me, please. So if I hit Control Enter, then it's going to say, yep, here's number 5. Okay? So this is a simple example. We're going to do a lot of that. If you don't get it right now, today, like why are we doing this, right? Why do we need variables? You will see that, okay? We'll go over a lot of examples, and hopefully by the end of the semester you will get perfect understanding why that happened, okay? I can record numbers, right? Numerical values inside my variable x. One more thing, by the way, before we move on, what I want to point out is this. R, just like Python, is case sensitive. Can you guess what that means? Yeah, what does that mean? Lowercase versus uppercase, okay? I just created a variable which I called lowercase x, not uppercase x, okay? What will happen if instead of saying, hey R, can you print for me variable which is called uppercase x? What do you think will happen? Let's try. Yeah, it will give me an error. Error, object x is not found, okay? Which actually brings me to another good point. Things that you see in the color blue. You see color blue? That means that these are normally executed lines, okay? I ran them. R does not object. There are no errors, and it is just fine, okay? Things that are colored red, remember we discussed pre-attentive attributes, right? Red is the error, right? Ooh, bad thing. So unless you fix that, nothing will happen, okay? So color red means an error, or sometimes it's a warning, okay? Hopefully we'll not bump into this, but last semester I had this, like we downloaded and installed certain libraries, but they were done in the previous version of R, and before running the function from this library, it gives you the warning. Hey, you just installed the library which is created under the older version of R, it may not work, just FYI, okay? So, warnings are not lethal, so to speak, okay? They're probably okay. If you continue, it should be fine, it should work, okay? But sometimes, like in this case, capital X doesn't exist, so therefore you have an error, my friend, in your code, right? Okay, so red color is generally speaking bad, blue color is generally speaking good. Alright, so this is an example of a variable which is integer, okay, or numerical. Let me just, doesn't matter if it's integer or decimal, it's a numerical variable. Alright, so variable x. Now here's what I can do. I can go ahead and, we're just experimenting today, right? I can go ahead and say, now instead of x equals 5, let's do another. So erase 5. Let's assign another value to the variable x. Now, Don, you have experience, right, with programming. What's the very first thing that every person learning programming does? What's the very first program? Hello world, right? Very first program is how to print hello world. Any language, okay? You start learning Python or Java or C++, guaranteed the very first example that will show you how to do it, print hello world. Let's do that, okay? Let's assign variable x, not the number 5, but a string. And I'm going to show it by quotation, okay? Quote unquote. That means that whatever goes inside is going to be a string, right? So hello world. Bam. Okay, like this. And again, I'm going to run it, go ahead and execute. And let me go ahead and type it out. So I'm going to say, please show me what's inside variable x. And it says, hello world. Note the quotation symbols. What are quotation symbols when I typed out 5? No quotation, it was just 5, right? Every time when you see quote unquote, that means that whatever you're printing out is a string of characters. Characters don't have to be alphabetical characters. If I go ahead and, actually, interesting experiment. What do you think will happen if I replace hello world with 5? It's going to be a number or a character? It's going to be a character, right? Because it's inside quotation marks, right? So if I run this line and print it out, it's going to show me 5 inside quotations. So even though it looks like 5, but it's not really a number. It's a character 5. Okay? This is, ladies and gentlemen, is a different data type. The one that I used before when I said x equals 5 without quotations. That's when I assign a numerical variable, a numerical value to the variable x. When I said x equals quote unquote 5, that's when I'm assigning string value to the variable x. Okay? Now, let me do another one. All right? Sometimes you have to check the condition, and condition can be either true or false. Okay? In this case, the result of the condition evaluation will be either true or false. So I'm going to say true, all capital uppercase. Okay? X equals true. So technically, as I'm looking at it, it should be a string, right? Not a number, right? It should be a string. But weirdly enough, I'm not using quotes. Did you notice? Yeah, so let's run it and see what happens. So I assign the value true to the variable lowercase x. Now I'm going to print it. So run this line, and it prints me out true, but notice there is no quotation symbols, right? So is it a string? No, it's not. This is a third different yet type of the variables that can exist, okay? The first one that we learned when you just say x equals 5, it's numerical, right? When you say x equals quote unquote 5, it's a string, right? Variables can be of the type string. Names, for example, right? Or majors of students, okay? They're not numbers. Or another one, another type that the variable can take is called logical. Sometimes it's also called Boolean. Okay? Logical test can be either true or, what's another one? False, right? So let's try that actually. So instead of true here, I'm going to type false, also all uppercase. False. Alright? And when I run both lines, x equals false, and type x, it'll tell false. Okay? So it's not a number. I shouldn't say that. Actually, technically I'm lying, and you will see hopefully in 5 minutes why. Okay, it can be interpreted as a number actually, right? But it's certainly not a string. So it's a special type of elementary data. It's called logical. There are only 2 values, true or false. Okay. Another thing that I want to tell you is this. In some languages, such as C++, before you assign a variable, a value, such as, for example, right here, right? I'm saying that there is a variable x, and the value inside of that is going to be false. In C++, I would have to define what type of data the variable can hold. For example, if I want to assign variable number 5, and 5 is integer, right? Before that, I would have to say int. That would be C++. That means that variable x is designed to hold only integer values. That's it. Okay? If I'm going to declare x as integer and later say x equals hello world, I will get an error. It will not go through the compiler. Okay? The compiler will throw an error. C++ and Java, I believe, does the same thing. They're called something that's called strongly typed language. Okay? So before I use a variable, I have to define precisely what type of data is going to hold inside. It's going to be numbers. Moreover, integers and float decimals are not the same. So if I want to record 5.3 in C++, I would have to say float. Floaty, float. So that means that is designed to have decimals, such as 5.2. Okay. If it's a character string, I would have to say this variable has a type char character, and then I'm going to say quote unquote hello world. Hello. Okay. R doesn't require that. In R, I can go ahead and say x equals 5. When I run this line, R will understand that, hey, 5 is integer, x is an integer variable. Or alternatively, I can go ahead and say x equals quote unquote 5. And R will understand, yep, there is quotation, right? There are quotation symbols. That means that this is a character, this is a bunch of symbols. Anything can be inside. It can be alphabetical characters, it can be numbers, it can be punctuation signs, space, underscore, what have you. Anything goes, okay? Or if I say equals true, all caps, right? Then when I run this line, R will say, yep, I understand that this is a logical Boolean variable, true or false, okay? So I don't have to tell R that this is integer, this is character, and this is Boolean, okay? So R, and Python the same thing, by the way, is something that's called loosely or weakly typed language. That means that you don't have to tell R what's inside the variable. Is it integer? Is it decimal? Is it character, string? Or is it logical, true or false? It will understand that in the runtime. As you run the command, it will see what value you're trying to assign this variable, and it will basically say, yep, it's an integer, so hence integer variable x. Okay? So, and that makes actually things simpler, believe it or not. Because I did some C++ programming early in the day, and I got to tell you, it's not, every time when you declare a variable, you have to say what's going to be stored in this variable. It's going to be integer, or decimal, or string, or a logical Boolean variable. Okay? How are we doing? Who is with me? Still paying attention? Alright, how much time do we have today? No time. Yeah. Okay. So I'm going to stop the recording right here, okay? But yeah, let's chit chat first about what's going to happen next week.